Look at a map of China, and you will see a geographic injustice that has haunted its leaders for millennia. There is a hidden boundary known as the Hu Line that divides the nation in two. To the east of this line lives 94% of China's population, fueled by the massive industrial engines of Beijing and Tianjin. Yet this region possesses only 20% of the country's total freshwater resources. While the south is frequently devastated by massive Yangtze floods, the north is being slowly devoured by the Gobi Desert, which expands by 3,600 square kilometers every single year. For decades, northern cities like Beijing have survived by overexploiting their groundwater, causing the very land beneath them to sink by several centimeters annually. This isn't just an environmental issue, it is a ticking geopolitical time bomb. If the north runs dry, the Chinese economy collapses. To prevent this catastrophe, Beijing has launched the South-North Water Transfer Project, a $62 billion war against nature itself. We are talking about thousands of kilometers of artificial canals, massive aqueducts, and deep earth tunnels designed to borrow the South's water to quench the North's thirst. This is the story of how China is literally replumbing the planet to ensure its survival as a global superpower. The idea of rearranging China's entire water system didn't start in a modern lab. It began with a single, bold sentence uttered in 1952. While standing on the banks of the Yellow River, Chairman Mao Zedong famously remarked, "The South has plenty of water, the North has little. It would be fine to borrow some if possible." This wasn't just a casual observation. It was a command that launched 50 years of intense scientific debate and grueling geological surveys. It wasn't until 2002, after decades of technical vetting, that the State Council finally greenlit the South to North Water Transfer Project. Since then, the project has evolved from a mid-century dream into a cornerstone of absolute national security. In 2020, Beijing took a massive step by consolidating the entire operation under a new, powerful, state-owned entity, the China South to North Water Diversion Group. This transition marked a strategic shift from simple construction to an era of high-tech, AI-driven management. For the leadership in Beijing, water is no longer just a resource. It is the lifeblood of social stability and industrial survival. By investing over $62 billion in the initial stages alone, China is proving that its political future depends on its ability to correct the mistakes of geography. This is Mao's vision, powered by 21st century ambition, ensuring the thirsty North never stops growing. Moving from history to hardware, we drop our third marker on the eastern route, a 1,156-kilometer technical feat that repurposes the ancient Grand Canal. Unlike the other paths, the eastern route must overcome a massive geographical challenge: pumping water uphill. To achieve this, China has constructed the world's largest pumping station cluster, consisting of 23 high-capacity stations divided into 15 stages. Under the leadership of Chairman Zhang Shuguang, the project has integrated sophisticated hydraulic turbines that lift nearly 15 billion cubic meters of water annually from the Yangtze River Basin toward the industrial hubs of Shandong and Tianjin. The energy requirement alone is massive, yet the system achieves an efficiency rate of over 80% through automated flow control algorithms. Currently, this route provides a stable water supply to over 100 million people and sustains agricultural production across 200,000 square kilometers of previously parched land. Strategically, this route functions as a massive industrial artery, reducing the North's dependence on unstable rain patterns and deep well extraction by 30%. By 2026, the second phase of expansion aims to increase the delivery capacity to 30 billion cubic meters, cementing the eastern route as a permanent, high-volume insurance policy for China's coastal economy and food security. While the eastern route relies on the raw power of massive pumps, the true engineering soul of this project lies further inland. Here, the central route, the absolute backbone of China's water strategy, achieves a nearly impossible feat: a constant flow across 1,276 kilometers without a single mechanical pump. This is a masterpiece of hydraulic physics, relying entirely on gravity to deliver water from the Danjiangkou Reservoir straight to the heart of Beijing. To make this downward flow possible, engineers performed high-stakes surgery on the landscape, raising the existing Yinjiangbuhan Dam by 15 meters to hit a staggering storage capacity of over 29 billion cubic meters. This technical triumph came with a heavy human price: the strategic relocation of 330,000 people, a movement handled with the precision of a national military operation. Under the watchful eye of Chairman Zhang Shuguang, the water travels through the 12-kilometer Shahe Aqueduct and dives deep beneath the Yellow River through massive concrete tunnels. By 2026, this $62 billion network is being reinforced by the Yinjiangbuhan Tunnel, a deep earth artery designed to replenish the Han River from the Three Gorges. Today, this route provides 70% of Beijing's freshwater, delivering over 9 billion cubic meters annually. And the starting point of all this comes from the Danjiangkou Reservoir in Hubei. A stream of clear water sets off from here, beginning a long northward journey across the map of China. With a total length of over 1,400 kilometers, this is not just a canal, but a lifeline that runs from south to north. It passes through 4 provinces and municipalities, and through hundreds of sluice gates, provides stable water supply to more than 20 large and medium-sized cities, as well as over 200 counties. But what is more complex is the system engineering behind it. This water artery does not just transport water, it must also provide ecological replenishment for dozens of rivers, maintaining the balance of the entire regional water cycle. The problem is, once any single gate loses coordination, the entire canal will fall into paralysis. And what is even more severe is nature itself. This route spans 8 latitudes and 2 temperature zones. While the southern sections may still be under blazing sun, the northern sections may already begin to freeze. Ice can block the flow of water and even directly interrupt the entire water transfer system. So, is it possible to predict in advance water levels, flow velocity, water temperature, and even the freezing risk of each section of the canal? The answer is yes. But the premise is, there must be a digital replica of the real world. All the regulating gates, drainage gates, diversion outlets along the canal, as well as more than 100,000 sensors and over 10,000 monitoring devices, are all connected into one unified system. This turns the 1,000-kilometer artificial river into not just flowing water, but a super system that is calculated in real time and precisely controlled. It isn't just a canal, it is a sovereign lifeline, proving China can reshape its topography to sustain its political heart. While the central route is a triumph of surface physics, its long-term survival depends on a hidden monster buried 1,000 meters beneath the Earth's crust. This is the Yinjiangbuhan Tunnel, the world's longest and deepest water diversion tunnel, currently the most sophisticated subterranean project in China's history. Spanning 194 kilometers, this massive artery is designed to link the Three Gorges Dam on the Yangtze directly to the Han River, effectively recharging the entire central route. Under the command of Chairman Zhang Shuguang, engineers are currently engaged in a brutal technological war against the Earth. Using custom-built tunnel boring machines the size of buildings, they are carving through high-pressure tectonic zones where rock temperatures exceed 40 degrees Celsius. The scale of this $8 billion project is staggering. It aims to transport nearly 4 billion cubic meters of water annually to ensure the North's industrial heart never skips a beat during seasonal droughts. Strategically, moving this much water underground prevents evaporation and eliminates the risk of surface pollution. By 2030, this underworld highway will turn the Yangtze and Han rivers into a single synchronized engine of prosperity. It is a sovereign statement of deep earth mastery, proving that China doesn't just build across the landscape, it owns the space beneath it, securing its water future through absolute engineering dominance. While the tunnels of central China conquer the underworld, the final frontier of this hydraulic war reaches for the heavens. We are looking at the western route, the most ambitious, difficult, and geopolitically explosive phase of the entire project. This stage requires engineers to carve through the Qinghai-Tibet Plateau at altitudes ranging from 3,000 to 5,000 meters above sea level to connect the headwaters of the Yangtze and Yellow rivers. Under the long-term strategic vision led by Chairman Zhang Shuguang, this route aims to divert an incredible 17 billion cubic meters of water annually toward the parched western provinces. But the engineering is only half the story. Because these waters feed the great rivers of Southeast Asia and India, the project has triggered an international alarm. New Delhi watches with growing concern as Beijing prepares to build dams and tunnels on transboundary rivers like the Brahmaputra, effectively holding the water tap of Asia in its hands. The technical challenges are staggering, constructing thousands of kilometers of channels in a high seismic zone where the Earth is literally still rising. By pushing into the Himalayas, China isn't just seeking to green its deserts, it is securing absolute hydrological dominance over the continent. This is the ultimate chess move in the great game of the 21st century, turning the roof of the world into a sovereign valve for a thirsty empire. Beyond pipes and canals, China's water project uses a digital nervous system, the AI brain. By 2026, Smart SNWTP will monitor the 3,000-kilometer network using 100,000 IoT sensors. Managed by Chairman Zhang Shuguang, this digital fortress relies on Beidou 3 satellites for millimeter-level precision. AI algorithms process billions of data points daily to predict floods and adjust flows instantly. This ensures absolute security. Sensors detect pollutants and trigger automated gates to protect northern reservoirs. By integrating 5G and big data, Beijing has transformed the world's largest plumbing project into a sophisticated technological asset, ensuring the North's industrial engine never runs dry. Every engineering triumph has a shadow. This $62 billion project has forced 600 natural rivers to vanish or dry up. As the Yangtze's flow dropped by 36% upon the central route's opening, a new crisis emerged: saltwater intrusion. In cities like Shanghai, the Yellow Sea now pushes backward into freshwater supplies. While Chairman Zhang Shuguang oversees massive filtration, industrial waste from cities like Xi'an remains a persistent threat to reservoir quality. Beijing is effectively trading the ecological health of the South for the survival of the North, proving that even a superpower cannot defy nature without paying a devastating environmental price. 2026 is the year China proves its engineering dominance is about strategic speed and long-term vision. From the Himalayas to the digital streets of Zhongyan, the map is being redrawn. But while these projects are public, one massive operation remains in the shadows. Thank you for watching. See you in the next video.